All right, in the first lecture, I covered this topic of morality and knowledge. I said last time that in his introduction to the fundamentals of ethics, Russ Schaefer Landau covers two main topics that I want to focus on. Last time we looked at this issue of morality and knowledge, or this issue of the possibility of moral knowledge and reasons that people have had for doubting the possibility of moral knowledge. Arguments for subjectivism or non-objectivism, this distinction between objectivism and non-objectivism. We covered that issue last time. And the other main topic that Russ focuses on in the introduction is the basics of logic, the rudiments of logic, the basics of evaluating arguments. And that's a very important topic to cover in the introduction because many of the readings in this class are going to be organized around the presentation of arguments. Part of the purpose of the class is for you to learn to think critically about arguments, and thinking critically about arguments is in part learning how to evaluate them by a couple of different criteria. Especially in the third unit of the class, when we get into applied ethics, especially there, the readings are organized around the presentation of arguments. Arguments will be presented on both sides of different contemporary moral controversies, different controversial questions in ethics today. We'll look at articles that present arguments on both sides of an issue, and you want to be able to think critically about those arguments. You want to be able to critically assess them, critically evaluate them. So how do you evaluate arguments? Well, a basic distinction that we make in logic is this distinction between validity on the one hand and soundness on the other hand. So when it comes to evaluating deductive arguments, and those are the kinds of arguments with which we're going to be that we're going to be focused on in this class for the most part. When it comes to evaluating deductive arguments, and that category of arguments is just going to be the focus of my comments today. There are those two criteria that we apply, or there are these two questions that we ask. One question would be, is the argument valid? And the other question would be, is the argument sound? So Schaefer Landau spends a good bit of time on this distinction in the introduction, and it's a little bit of a subtle distinction, and it takes students a certain amount of practice to get the hang of using this distinction between validity on the one hand and soundness on the other. So I'm going to take some time to go through that distinction a little more slowly, a little more carefully here, give you some more examples to help you learn how to work with this distinction. Validity has to do with the logic of the argument. It has to do with the reasoning of the argument. How did you get from the evidence to the conclusion? How did you get from the reasons to the conclusion? Was that reasoning good reasoning? Was that reasoning logically correct reasoning? That's what is involved in this term valid. That's what we mean by this concept of validity, or the concept of an argument being valid. Valid means that the reasoning in the argument is correct. That's not the only assessment that we make of an argument. Of course, the reasoning does have to be correct reasoning, does have to be logically correct reasoning for an argument to be a good argument. But it's also, of course, the case that the evidence presented, or the reasons presented in support of the conclusion, those premises have to be true for it to be a sound argument. So there's only one condition for an argument to be valid. There's only one criterion. The reasoning simply has to be correct reasoning. There are two conditions that have to be met for an argument to be sound. There are two criteria for soundness. The argument has to be valid, so again, the reasoning has to be correct, and the premises have to be true. So the premises are the statements in an argument that set forth the evidence or the reasons offered in support of some conclusion. So sound is a broader evaluation. Valid is a relatively narrower evaluation. First, we just evaluate the reasoning, and the reasoning in an argument involves a kind of inferential claim. The a kind of inference is being made, and implicitly the inferential claim is that the evidence presented in the premises, or the reasons presented in the premises, support the conclusion in such a way as to establish it. Now that may or may not be true, but that is a claim, at least implicitly, that every deductive argument makes, this inferential claim. When it comes to determining that the argument is in all things considered good argument, that's really what we mean by sound. We do evaluate the inferential claim, that is to say the claim that the reasoning of the argument is correct reasoning, but then we also evaluate the factual claims that are made in the argument. Are the premises put forth factually true? So sound is the broader evaluation that we make. And again, this is a subtle distinction. It takes students a little bit of practice to get the hang of using this distinction. But they are conceptually distinct. This issue, on the one hand, of whether the reasoning of the argument is correct reasoning, and this issue, on the other hand, of whether the premises, the statements in the argument that present the evidence or reasons, this issue of whether the premises are true. Here's one way that I would explain this distinction, or one way to help you think about this distinction. I'm going to give a lot of examples, but here's just one real quick example. One way that I would make the point would be to say that, of course, you can reason correctly on the basis of false information. If the information that you're given is faulty, if the information that you're given is false, you can still reason logically on the basis of whatever information that you have. Oftentimes that's the case in life. Oftentimes that's the case in science, for example. When scientists are trying to discover the truth, they don't know whether the information they have is correct or not. But they still want to be able to think logically about what would be the implications, what would be the logical implications if certain hypotheses, say for example, were true. So being able to reason correctly, logically, even when we're not sure whether the evidence that we're going off of is true, is an important intellectual skill. So here's one way that I would make the point. Again, my point being that you can reason correctly on the basis of false information. That's why this issue is the reasoning. This issue is the reasoning in the argument correct. That's one issue. And on the other hand, are the statements in the argument true? That's a different issue. You can reason correctly on the basis of false information. So what would be an example? Suppose that you falsely believed that Dallas was north of Amarillo. And suppose that you falsely believed that Amarillo was north of Denver. Okay, well, given those two false beliefs, what would be a rational inference? What would be a reasonable inference? What would be a logically correct inference? If you were to infer from those two statements that Dallas is north of Denver, that would be a logical inference. That would be a valid inference. You would be reasoning correctly on the basis of the information that you have. The information that you have turns out to be false, but you were reasoning correctly. You were applying correct logic. So let me give some more examples of what I mean here by validity. Let's take a look at some examples that bring out this distinction between valid arguments on the one hand and invalid arguments on the other hand. This argument on the left is an example of a valid argument. If it rained last night, then the grass is wet. Premise 2, it rained last night. Therefore, conclusion, the grass is wet. That's a valid argument. Now here again, what do we mean in saying that that's a valid argument? As I said a moment ago, we mean that the reasoning in this argument is correct reasoning. One way that you can see that it's correct reasoning is to ask yourself this question. If these premises are true, is this conclusion necessarily true? And the answer is yes. If premises 1 and 2 are true, this conclusion is necessarily true. Or to say the same thing a different way, to put the point in a different way, it is not possible for these premises to be true and this conclusion turn out false. That's what we mean in saying that a deductive argument is valid. Let's take a look at this second argument. Premise 1, if it rained last night, then the grass is wet. Premise 2, the grass is wet. Therefore, conclusion, It rained last night. All right, that's an invalid argument, and it sounds very similar to the first argument, so it might be a little bit hard for you to see why the one is valid and the other is invalid. But now let's apply that test that I talked about a moment ago to this second argument, this argument on the right. Is it possible for these premises to be true and yet this conclusion turn out to be false? I said in the case of this first argument that is not possible. If these premises are true, this conclusion is necessarily true. But is that the case with respect to this second argument? No, it is not. Let's think about this first premise. If it rained last night, then the grass is wet. Okay, that's a conditional statement, and let's stipulate that that is a true conditional statement. Second premise, the grass is wet. Okay, now that refers to we would have to know what specific time and place we're talking about, obviously, but let's suppose that we're in a time and a place where that happens to be true. Yes, the grass also happens to be wet. Also, okay, so both of these premises are true. Is it possible that in that scenario, where this statement is true and this statement is true, is it possible that in that scenario, this statement, the conclusion, is false? Yes, it's possible. It does not follow from the truth of these two premises that it rained last night, right? The grass could be wet for some other reason. So the premises would be true, and yet the conclusion could still be false. So that's why I say that this second argument is an example of an invalid argument. So that first argument is a common form of valid deductive argument. The form of that first argument that we said was valid is this: if P then Q, P therefore Q, where P and Q are variables. These variables stand for statements. So the variable P stands for the statement, it rained last night, and the variable Q stands for the statement, the grass is wet. So you'll recall that the example that we just gave of a valid argument was, if it rained last night, then the grass is wet. It rained last night, therefore conclusion, the grass is wet. So P and Q are just variables. You could substitute any statement for those variables, and the argument would still be valid, because modus ponens is a valid form of reasoning. Now, of course, the statements that you substitute for those variables, P and Q, they might not be true. But as I said a moment ago, you can still reason correctly on the basis of information that isn't true. So any argument that falls into that pattern, if P then Q, P therefore Q, is going to be a valid argument, because that's a valid form of reasoning. That argument, any argument of this form, modus ponens, always satisfies this test. If the premises were true, would the conclusion be necessarily true? That's always going to be the case with any argument of this form. Any argument of the form modus ponens. That second argument that we said was invalid sounded very similar to the first argument, and yet when we look at the form of the argument, you notice that there's a difference that makes a big difference to the correctness of the reasoning. The first premise was the same statement. If it rained last night, then the grass is wet. The second premise was the grass is wet, and the conclusion was therefore it rained last night. Well, as we said, that's an invalid form of reasoning. And any argument that falls into this pattern is invalid. Even if the statements that you substitute for the variables P and Q, even if those are true statements, this is still always going to be an invalid argument. Because with respect to an argument of this form of common formal fallacy called affirming the consequent, it's never going to be the case that the truth of the premises guarantees the truth of the conclusion. So this is a common formal fallacy. It's called affirming the consequent. It's any argument of this form, if P then Q, Q therefore P. That's always an invalid form of reasoning. Here again, there are some common forms of valid deductive argument that we'll talk about. One of them is modus ponens, and that's always a valid form of argument. There are some common formal fallacies, some common logical errors, let me put it that way, that we'll talk about as well, and one of them is affirming the consequent. That's a fallacy. It's any argument of this form, if P then Q, Q therefore P. That's always an invalid form of reasoning. So, I said a moment ago that valid means the reasoning is correct. How do you know whether the reasoning is correct? One way that you might know would be to recognize the form of the argument. If the form of the argument is modus ponens, then you know that it's correct reasoning. But you're not going to know the name of every valid form, so there has to be a more general way to know whether the reasoning in an argument is correct reasoning. So there's a test that you can apply. There's a standard that you can apply to make that determination. There's a test of validity, and the test is this. Just ask yourself, if the premises were true, and put to the side the question of whether they actually are true, put to the side the factual claims made in the argument, and just for the purpose of validity, just focus on the inferential claim. And ask this question, if the premises were true, would the conclusion be necessarily true? That is to say, is it possible for the premises to be true and yet the conclusion be false? If that is possible, then the argument is not valid. If it's impossible for the premises to be true and the conclusion be false, then the argument is valid. So that's the test of validity, and you can apply that to any deductive argument. Now, one way that we come to see that invalid forms are invalid is to use what we call the counterexample method in logic. That is to say, give an argument of exactly the same form that has obviously true premises and an obviously false conclusion. So the second argument that we looked at, again, was this affirming an example of this affirming the consequent fallacy. Again, it was an argument of the form of P then Q, Q therefore P. Now, in the case of the example that I gave, it might have been a little bit hard to see that the argument was invalid because it so closely resembled the example of a valid argument that we gave. So I'm going to construct a counterexample to this argument, an argument of exactly the same form with obviously true premises but an obviously false conclusion. So here's a counterexample to that second argument. Premise 1. If there are more than 1,000 people in this room, then there are more than 10 people in this room. Of course, that conditional statement is always true. Premise 2. There are more than 10 people in this room. Okay. Well, just imagine yourself in a scenario where, say, for example, you're in a classroom and there are more than 10 people in the classroom. Just imagine yourself being in that scenario. So imagine a scenario in which premise 2 is also true. So it's not hard to think of examples of when you've been in a room with more than 10 people. So common scenario, we've all been in that scenario many times, so it's not hard to imagine scenarios or examples in which both of these premises would be true, and yet the conclusion, there are more than 1,000 people in this room, would be false. Probably no classroom that you've been in has had more than 1,000 people. So this is a counterexample to that second argument. It shows that any time the argument is of this form, if P then Q, Q therefore P, it's not going to be the case that the truth of the premises guarantees the truth of the conclusion. Because here the premises are true, and yet the conclusion is false. So obviously, the truth of the premises did not guarantee the truth of the conclusion. That's why we say that that form of argument is invalid. Here's another example, another counterexample to the form of argument affirming the consequent. Again, affirming the consequent is any argument of this form if P then Q, Q therefore P. Here's an example, again, where the premises are true but the conclusion is false. This is an example of affirming the consequent. The form of this argument is if P then Q, Q therefore P. So in this case, this variable P, in this case for the variable P, I should say, we would substitute the statement George Washington was beheaded. And for the variable Q, we would be substituting the statement George Washington is dead. So when we apply those two statements, when we substitute those two statements for the variables, we would get this argument. If George Washington was beheaded, then George Washington is dead. Well, of course, that conditional statement is true. Anyone who has been beheaded is dead. Second premise, George Washington is dead. That is also true. Died quite some time ago. First president of the United States died quite some time ago, obviously. So both of the premises are true, and yet the conclusion is false. It's not true that George Washington was beheaded. So this is another counterexample, another way of showing that any argument of that form, if P then Q, Q therefore P, is an invalid argument. Let's take a look at another example of a valid and an invalid form. Starting with this argument on the left. If it rained last night, then the grass is wet. The grass is not wet. Therefore, it did not rain last night. All right, that's a valid argument. Here again, what did I say is the test of validity? If the premises were true, would the conclusion be necessarily true? I want to suggest that this argument passes that test. If premise 1 and premise 2 are both true, then it is not possible for the conclusion to be false. If premise 1 and premise 2 are both true, then the conclusion is necessarily true. Let's take a look at an invalid argument that sounds very similar to that valid argument. Premise 1, if it rained last night, then the grass is wet. Let's agree that that is true. Premise 2, it did not rain last night. Okay, let's imagine a scenario in which that is true. So imagine a scenario in which both of those statements would be true. Would this conclusion, though, follow? Therefore, the grass is not wet. Well, no, that conclusion isn't necessarily true, is it? That conclusion could turn out to be false, couldn't it? It might be the case that the grass is wet for some other reason, like the sprinklers were left on or something like that. So it's not hard to imagine a scenario in which both of these premises are true and yet the conclusion is false. Well, that means that the argument has to be invalid. Because as we said a moment ago, if the argument were valid, the truth of the premises would guarantee the truth of the conclusion. But obviously that's not the case here, since we can think of lots of examples where the premises would be true, but the conclusion could turn out to be false. So that first argument, the valid one, is an example of a common form of deductive inference called modus tollens. Modus tollens is any argument of this form. If P then Q, it's not the case that Q, therefore it's not the case that P. Well, that's a correct form of reasoning. Anytime you're reasoning that way, you're reasoning correctly. It doesn't matter what statements you substitute for P and Q. That's always going to be a valid argument. So again, in this case, we were substituting for the variable P the statement it rained last night, and we were substituting for the variable Q the statement the grass is wet. But it doesn't matter what statements you substitute. That's always going to be a valid argument. If you substitute false statements, then it's not going to be, it may not be a sound argument, but that's always going to be correct reasoning. That's always going to be valid. That second argument was an example of a common formal fallacy, denying the antecedent. And that fallacy is anytime somebody reasons in this way, if P then Q, but it's not the case that P, therefore it's not the case that Q. That's an incorrect form of reasoning. That's a logical fallacy. With respect to this form of argument, if P then Q, not P, therefore not Q, it is possible for the premises to be true and the conclusion still turn out false. The truth of the premises in that case does not guarantee the truth of the conclusion. So let me bring out this point a little more clearly with a counterexample. Here again, in the case of these two arguments, it might have been hard for you to see why this one is valid and this one is invalid. But that's the value of the counterexample method. You learn to give an argument of exactly the same form that has obviously true premises and an obviously false conclusion. If you can do that, then you've proven that the argument is invalid. So let's give a counterexample to this second argument to show that it's invalid. Consider this argument. If he earned a B+, then he passed the class. Premise 2, he did not earn a B+. Therefore, conclusion, he did not pass the class. All right. Can you imagine a scenario in which both of these statements were true and yet the conclusion turned out to be false? Yes, it's not that hard to imagine such a case, right? Let's think about this first statement. If he earned a B+, then he passed the class. Of course, that's true. B+ is on any scale, right? B+ is always a passing grade. Premise 2, he did not earn a B+. Okay, let's imagine a scenario in which that is true. maybe he earned an A minus. Okay, so in that scenario, both of these statements would be true. But would this conclusion be necessarily true? Therefore, he did not pass the class. No, that doesn't follow. That would be a scenario in which these premises are true, but the conclusion is false. So we would say that that is an invalid argument. And this is a counterexample that shows that that form of reasoning is not valid reasoning. Here's another counterexample to that same form of argument. Again, that's a common formal fallacy, a common error in reasoning. Anytime somebody reasons in that according to that pattern, you know, if P then Q, but it's not the case that P, therefore it's not the case that Q, that's always an invalid argument. That's always faulty reasoning. That's always logically erroneous. That's not correct reasoning. Here's an argument that is an example of that form. Substitute for the variable P the statement Penelope Cruz was born in Barcelona. Substitute for the variable Q the statement Penelope Cruz is Spanish. Now I would give you this argument. If Penelope Cruz was born in Barcelona, then Penelope Cruz is Spanish. Penelope Cruz was not born in Barcelona. Therefore, conclusion, Penelope Cruz is not Spanish. Okay, let's think about these premises. Here again, the test of validity is this. If the premises were true, would the conclusion be necessarily true? Or to say the same thing a different way, does the truth of the conclusion guarantee the truth? Does the truth of the premises guarantee the truth of the conclusion? Or to say the same thing a slightly different way, is it possible for the premises to be true but the conclusion be false? Those are the relevant kinds of questions to ask when you're trying to determine whether an argument is valid. So let's think about this conditional statement, premise 1. If Penelope Cruz was born in Barcelona, then Penelope Cruz is Spanish. That statement is true because anybody born in Barcelona is Spanish. So that's a true statement. Premise 2. Penelope Cruz was not born in Barcelona. That's true because she was born in Madrid. Okay. Therefore, conclusion, Penelope Cruz is not Spanish. Well, obviously that conclusion is false. I just said that she was born in Madrid. Anybody born in Madrid is Spanish. So here we have a scenario in which the premises are true, but the conclusion is false. So obviously the truth of the premises did not guarantee the truth of the conclusion. So to say the same thing a different way, it is possible for the premises to be true and the conclusion turn out false. In this case, not only is it possible, but it's actual because the premises are true and it's actually false that Penelope Cruz is not Spanish. So this is another way of bringing out the invalidity of a form of argument. Construct a counterexample. An example of the argument that has exactly the same form as the given argument and that has obviously true premises and an obviously false conclusion. All right, let's talk a little bit more about validity and soundness. Let's take a look at this argument on the left. DeKalb is north of Peoria. Premise 2, Peoria is north of Carbondale. Therefore, conclusion, DeKalb is north of Carbondale. That's a valid argument. And you should be able to see that that is a valid argument. Here again, apply this test. If the premises were true, would the conclusion be necessarily true? This argument does pass that test, doesn't it? If these premises are true, that conclusion is necessarily true. Now, you may not know anything about the geography of Illinois, so maybe you don't know whether these premises are true. I want to point out that you don't need to know the truth value of the premises to determine validity. That's my point with this example. You could know nothing at all about the geography of Illinois and still see that this is a valid argument and still see that this is correct reasoning. Now, I'll tell you that these premises do happen to be true. So if you didn't know these premises were true, I can tell you that they are. So this is not only a valid argument, but it's a sound argument. The reasoning is correct, and it so happens the premises are true. So this is also a sound argument. Let's think a little bit more about this distinction between validity and soundness. Let's take a look at this example of an argument that is valid but unsound. Premise 1, Santa Barbara is a city in California. Premise 2, California is a province of Canada. Therefore, conclusion, Santa Barbara is a city in Canada. That's correct reasoning. That's a valid argument. If those premises were true, that conclusion would be necessarily true. If those, let me put the point in a slightly different way, if these premises were true, it would not be possible for this conclusion to be false. The truth of these premises would guarantee the truth of this conclusion. So that's correct reasoning. That is correct logical reasoning. That's correct logic. Now, it so happens, so here again, with respect to what I called the inferential claim, the claim that the premises establish the conclusion, that claim that is implicitly made in this argument is correct. But in logic, we distinguish between what we call the inferential claim on the one hand and what we call the factual claims in the argument on the other hand. And the factual claims are the claims made in the premises. This first premise, Santa Barbara is a city in California, that is true. But this second premise, California is a province of Canada, that's false. And because that's false, we say that this is an unsound argument. The reasoning is correct, but not all the premises are true. So the conclusion is, so the argument is unsound. Let's think a little bit more about this distinction between validity and soundness. One way to bring out the distinction is to point out that a valid argument can have false premises. Here again, as I said earlier, and I've given a few examples now, you can be reasoning correctly on the basis of false information. So let's consider this example. Premise 1, all dogs are trees. Premise 2, all trees are books. Therefore, conclusion, all dogs are books. Clearly, the reasoning in this argument is correct. So the argument is valid, although of course it's unsound. Here again, why do I say that the argument is valid? Why do I say that the reasoning is correct? Apply the test of validity. If these premises were true, would this conclusion be necessarily true? If you think about it a little bit, I think you'll agree that is the case here. If these premises were true, it would not be possible for this conclusion to be false. Obviously, the premises are false. All dogs are trees is obviously false, and all trees are books is obviously false. So it's going to be an unsound argument, of course, because again, there are two conditions for an argument to be sound. The argument has to be valid, and the statements in the argument, the premises, I should say, have to be true. So this is an example of a valid argument with false premises. Again, we make this distinction between the correctness of the reasoning on the one hand and the truth of the statements in the argument on the other hand, the truth of the premises on the other hand. Those are two different issues. And to recognize that and to keep that in mind and to be attentive to that distinction when you're evaluating arguments, that takes a little bit of practice. It's a subtle distinction. But that's why I'm giving you lots of examples and giving you lots of practice with this distinction. Now, let me talk a little bit more about what I've called the counterexample method here. Here again, when you are trying to show that an argument is invalid, the way to do that is to construct a counterexample. That is to say, give an argument of exactly the same form that has obviously true premises but an obviously false conclusion. If you can come up with a counterexample, then you've proven that that form of argument is invalid. You've proven that because there are no counterexamples to valid arguments. There are only counterexamples to invalid arguments. So if you've come up with a counterexample, a statement that has obviously true premises and an obviously false conclusion, then you have proven that the form of that argument is an invalid form. So that's the idea behind what I've called here the counterexample method. Give an argument of exactly the same form, but that is clearly invalid. So consider this argument. Every dog has a heart, every mammal has a heart, therefore every dog is a mammal. That's an invalid argument. And I know from experience that it's hard for some students to see that that is an invalid argument. But I want to suggest that the reasoning in this argument is incorrect reasoning. It's not logically correct reasoning. It's fallacious reasoning. It's hard for students to see that because every dog has a heart is true. and every mammal has a heart is true, and every dog is a mammal is true. All those statements are true. But here again, as I've said a few times now, in logic we distinguish between the factual claims that are made in an argument, and all these factual claims in this case are true, but we distinguish between that on the one hand, and on the other hand, the inferential claim that is made in an argument. The inferential claim here, the inferential claim implicit in this argument is that the truth of these premises makes this conclusion true. But that isn't so. That isn't true. This is an invalid form of argument. The premises are true and the conclusion is true, but this is invalid because the truth of the premises doesn't make the conclusion true in this case. In this case, the conclusion just happens to be true. It just kind of accidentally happens to be true. It happens to be true for reasons that have nothing to do with the truth of the premises. That's why this is an invalid argument. So again, this distinction between validity and soundness, it is a little bit subtle, and it does take a little bit of practice before students really get the hang of using it. Here again, as I said a moment ago, a valid argument can have false premises. This argument was valid, even though the premises were obviously false. And now I'm making the point that an invalid argument can have true premises. Every dog has a heart and every mammal has a heart. Those are both true, and yet this argument is invalid. So keep those points in mind, and that'll help you to understand this distinction between the correctness of the reasoning on the one hand, the correctness of the logic of the argument on the one hand, and then this separate issue of whether the premises in the argument are true. That's a different issue. Now, here again, it may be hard for you to see that this argument is invalid since all the statements are true. But if you just think about it a little bit, I think you'll agree it's not hard to come up with an argument of exactly the same form in which the premises are obviously true, but the conclusion is obviously false. So the form of this argument is roughly every x is f, every y is f, therefore every x is y. That's roughly the form of the argument. But now, what if we plugged in something different for x and y? So we would be, here again, every x is f is the form of this statement, so we're substituting the word dog for the variable x, and we're substituting for the variable f, the predicate has a heart, and we would be substituting for the variable y, the word mammal, and again, f, the predicate would be the same predicate, has a heart. So I would identify the form of this argument as every x is f, every y is f, therefore every x is y. That's not a valid way to reason. That's not a logically correct way to reason. That's invalid. Now again, that may be hard to see because in this case the premises are true and the conclusion is true. But again, to my point a moment ago, here again the conclusion just happens to be true for reasons that are independent of the truth of the premises. So what would be a counterexample to this argument? Well, here again, how do you prove that that's an invalid argument? I want to suggest that you can prove that this argument is invalid simply by constructing a counterexample. Give an argument of exactly the same form that's clearly invalid. Now here again, what did we say is the test of validity? If the premises were true, would the conclusion be necessarily true? That's the test that an argument has to pass for us to say that the argument is invalid. In a counterexample, the premises are true and the conclusion is false. So obviously, if you come up with an example in which the premises are true and the conclusion is false, then obviously it is possible, with respect to an argument of that form, it is possible for the premises to be true and the conclusion be false, because you've just given an example in which that's the case. So that's what, here again, what I mean by the counterexample method. So here's an argument of exactly the same form. Every x is f, every y is f, therefore every x is y. Okay, in this case, every dog has a head, that's true. Every cat has a head, that's true. Every dog is a cat, that's obviously false. So this argument is of exactly the same form as the argument that I just gave. And here again, in the case of this argument, it may be hard for you to see that the argument is invalid because all the statements are true. But here again, that's the value of the counterexample method. It teaches you to think in terms of the form of the argument rather than the content. Content is important when we're trying to determine is the argument sound. But the content, again, the factual claims in the argument, we put those to the side when we're just trying to determine whether the reasoning is logically correct reasoning. So this argument is of exactly the same form. Every dog has a head, every cat has a head, therefore every dog is a cat. Obviously true premises, an obviously false conclusion, so we have proven that that form of argument is an invalid form.